In this video, we're going to look at section 6.3, multiplying fractions. So I think this section will be very different from how you typically may teach multiplying by fractions. So traditionally, we might just take two fractions and multiply them and show the algorithm. But here there's some core ideas that we really want them to understand about the usefulness of multiplying by fractions, because this is something that we do a lot, especially in proportional reasoning. And the application problems you'll see that they have a lot of trouble with. So let's look at the first one. Ebony ate 1/3 of a pizza. The pizza had 12 slices. How many slices did she eat? So first, notice in terms of units that we're changing our unit throughout this problem. We start with 1/3 of a pizza, so a pizza is the unit. Then we cut the pizza into 12 slices, and then our question is asking about the number of slices she ate, so the slices are the unit. Okay, so if we had asked Ebony ate 1/3 of a pizza, the pizza had 12 slices, how much pizza did she eat? That would be a bad question, because how much pizza wouldn't be a unit of measure that we could clearly differentiate. Okay, so just looking at these in two different ways, it's 1/3 of a pizza, okay, and here we have 1/3 as a number, and then when we refer to the 12 slices, now we're looking at 1/3 of 12. So notice these two map to one another. This is 1/3. The diagrams look very similar, except this one is cut into 12. But here, when we're looking at the unit of slices, 1/3 is actually 4, and 1/3 of 12 is 4. That's how we're getting the value of 4. Okay, so they need to see, if they do this by hand, that when they're finding 1/3 of 12, it's 1/3 of a copy of 12. Okay. They can think of it as 1 for every 3 slices. So one way to have them do this is to count 1, 2, 3, 1, 2, 3, 1, 2, 3 all the way around. Okay, or they can notice that they're dividing the 12 slices into 3 equal groups. Okay, and they have 4 groups, and they're taking 1 copy of 4. Okay, so notice how these conceptions of this are a little bit different. So we talked about this in division, I believe in Unit 1, where we talk about partitioning into groups. So 12 divided by 3, we can say how many copies of 3 are in 12, and that's where we're getting the 4. Or this idea is kind of like the dealing out the deck of cards. Okay, you're dealing out the slices to 3 spaces, and you're taking 1 out of every 3. Okay, so both of these ideas are useful, and they could use either strategy for finding what 1/3 of 12 is. Okay, but we want them to see this eventually, this algorithm, that what are we doing when we take 1/3 of a copy of 12? The denominator of 3 is cutting the 12 into 3 equal pieces, which gives us 4. Okay, and here at this point, you can start to connect the idea. You multiply the numerators, you multiply the denominator. 12 over 3 is 4, and 12 over 3 is another way that we can write 12 divided by 3. Okay, so again, we're just starting with unit fractions to develop this idea, and this idea is not trivial, you will see. Here we have a continuous model. Kimber was 25 miles from home, or 20 miles from home. She traveled 1/5 of the distance. Okay, so here we're thinking of 1/5 of the distance. Our unit is 1. Okay, so the distance, and I know that sounds weird, but it's 1 distance, or 1 total length of the trip. Okay, and then we're changing the units to miles, where 1 whole trip is 20 miles. Okay, so this idea of double number lines, we'll use this a lot in proportional reasoning. Okay, and if we cut this into 5 equal pieces, we can cut this into 5 equal pieces, and 1/5 corresponds to dividing 20 by 5, which is 4. Okay, so really there's a lot of ways to get them to see these connections, and finding just a fraction of a whole number, you'll see that is just a difficult task for them, so you really want to build it. Here's one where they don't get a whole number answer. Okay. And you can have them draw directly on this diagram. So Logan has a 5-gallon bucket. He fills it 1/4 of the way to the top. How much water is in the bucket? Okay, so here's the bucket. Oh, I can't draw there. Okay. Well, 1/4 of the way is splitting this into 4 equal pieces. That's right here. How does that map to the number of gallons over here? Okay. Well, a nice start is they can notice that it's between 1 gallon and 2 gallons. Okay. They can also take 1 out of 4, okay, because it's 1/4, and then look at the last gallon. So let's pretend we're zooming in on the last gallon on top. Cut that into 4 pieces, take 1 of those. That's 1/4 gallon. And then talk about how, well, the water or whatever's in it, water, would sink down to the bottom, and that would be 1 1/4 gallons. Okay, so really getting them to visualize this and make sense of this in context, because this is an idea they're definitely going to need for multiplicative and proportional reasoning. Okay, so we're not just multiplying the numerators and multiplying the denominators. Yes, that's a quick way to do it. Okay, but if they're just doing that and they don't have this underlying meaning to connect it to, they're really not going to benefit much from being able to multiply some numbers. Okay. Here we do the same types of problems, but we change it from a unit fraction to a composite fraction. Okay, so 2/3 of the 12 slices. So think of how you might do this. So we know it's 2/3 times 12. Okay, but it's likely that you would take 1/3. Okay, you might say cancel out the common factor of 3, but 1/3 of 12 is 4, and then you take 2 copies of the 4, which is the multiplication of 2 times 4, to get the 8 slices. Okay, so this idea of the denominator cuts. Okay, the numerator is the number of copies, and now we're acting on a different number. So before we were just, for 2/3, we're just saying cut it into 3 pieces, take 2 copies. Now we're saying, and this was our unit, and 2/3 was just a number. Now we're saying, well, this is equal to 12, or represents 12. Cut 12 into 3 pieces. Each piece has size 4. Take 2 copies, and that's 8. Okay. Same idea with the next one. Cut 20 into 5 pieces. Each piece has size 4 again. Take 3 copies, and that's 12 miles. And then you have the same idea with the bucket. Okay. So that's the first idea with multiplying fractions. Then we're going to look at multiplying whole numbers and fractions. Remember the last one, we were multiplying fractions and whole numbers. So yes, multiplication is commutative, but if we have, if we're using the copies of, so we had 1/3 times, 5 is 1/3 of a copy of 5. And if we write 5 times 1/3, that's 5 copies of 1/3. And if we have the whole number first, you can see that this lends itself nicely to repeated addition model. Okay, so if you have 5 copies of 1/3, since it's a whole number of copies, we can think of adding 1/3 to itself 5 times. Okay, then they could use their addition ideas. That would be 5/3, and they could say, oh wow, look, you just multiply the numerators and denominators, and this makes sense. Okay, so again, this is an application problems, and I've seen students have trouble with these in the past before we really delineated between these type of problems and general multiplication. They don't see that it's a multiplication problem within the context. We start with just 2 whole numbers, so we can show them 3 packs of cupcakes, 4 cupcakes each. That would be 4 plus 4 plus 4. So that's going back to Unit 1. And then we start looking at fractions. Okay, so the idea here, Anderson jogged around a lake 5 times. Distance around the lake is 1/3. How far did he run or jog or whatever? So here we are at 0. That's his first trip around the lake, second, third, fourth, fifth, and they can see 5/3 and connect that idea to the multiplication. Okay. Here's one with a composite fraction. So 7 people, 2/5 of a pound of cold cuts per person. So they could count by 2/5, 7 copies of 2/5, and then they can connect that idea that it would be 14/5. Now we have multiplying 2 fractions. Okay, so in most of these examples, if not all, it's a part of a part, meaning that we have a fraction, a proper fraction of a proper fraction. Okay, this is a really great way to start this idea and have them think about it. So Cameron walked 1/3 of a mile to school. So here's this represents 1 mile. It's cut into thirds. Today, Cameron's friend picked him up after he had walked halfway to the school. So we're finding 1/2 of 1/3. Okay, and this is really an idea that they can relate to. Okay, and they know that if he walked half of the way to the school, it has to be less than the 1/3 he walked before. Okay, and some students will say 1/6, and I encourage you to get them to justify that to see if they see the reasoning behind it. Sometimes they just say, oh, I multiplied them, and they may actually understand why they multiplied them, but you want the whole class to see that connection. So if you're taking half of 1/3, you're cutting the thirds into halves. So there are your thirds. Okay. Half of 1/3 would be halfway between 0 and 1/3. Okay, and then to get an idea of what this represents, if you cut the whole unit, the thirds of the whole unit into halves, you can see that it's 6 equal segments, so this must be 1/6. Okay. Then, so that's a number line example. Then we can look at an example with area. These come up a lot. And we also have some Math AS problems that help them visualize this idea. Okay, so Jesse bought a rectangular piece of land. The land is 2/3 of a mile long, 3/4 wide. How many square miles did he buy? Okay, so we have 2/3. Okay, and notice it says 1 mile by 1 mile. So we're using a unit of 1 square mile. Okay. Let me change colors. Then we have 3/4. So I'm going to cut this way into quarters. Okay. So this right here is 3/4 of 1. This is 2/3 of 1 going all the way across. So if it's 2/3 by 1/4, it's this 1, 2, 3, 4, 5, 6 pieces. And notice the total number of pieces in the unit is 12. Okay. So 2/3 of 3/4 is 1/12 of a square mile. Okay, and we're going to continue this on the next video because I'm almost out of time, sorry.